All right, let's finish up the exponent rules. We talked about the product rule and the quotient rule. That leaves us the power rule, and actually the power rule has three parts. This first part applies when you're raising a power to a power, and this example is the one that folks frequently would miss if this was multiple choice because of not understanding when to multiply the exponents and when to add the exponents. Folks would be sitting there going, is this x to the fifth or is it x to the sixth? If you think about what cubing something means, though, that answer will become apparent to you. Cubing something means multiplying it by itself three times. So x squared cubed means multiplying x squared times itself three times. And we could break that down farther if we wanted to. We could say that means x times x times x times x times x times x, and we can see that we have six x's that are multiplied together. That's x to the sixth, and that's what we would have gotten if we had originally multiplied those exponents. So when you raise a power to a power, that's when you multiply the exponents. A to the m to the n is a to the m times n. The second power rule tells us when we have a product to a power, we can just raise each factor to the power. For example, if we have 5x cubed squared, we can just square the 5 and square the x cubed. And we probably wouldn't leave that as our answer because 5 squared simplifies to 25 and x cubed squares simplifies to x to the sixth. That's when you multiply the exponents. So as long as you have a product, as long as you have multiplication inside the parentheses raised to a power, you can raise each individual factor to the power. And number three helps us deal with fractions to an exponent, which is nice because if I was evaluating 2/3 to the fourth on the test and I entered it on my calculator, most calculators would give me a long, ugly decimal answer for that, and I would have to round it or use bar notation to show what's repeating. I don't want to write that long, ugly decimal. A rule that I want you to go by this semester is if the original problem has a fraction in it, I want that answer as a fraction. To raise 2/3 to the fourth power, you can simply raise the 2 to the fourth power and the 3 to the fourth power. The quotient rule, excuse me, the third power rule says a fraction raised to a power can be evaluated just by raising the numerator to the power and the denominator to the power. Of course, you can simplify that further. 2 to the fourth is 16 and 3 to the fourth is 81. I would want you to give me 16 over 81 as that answer than a long decimal that you've rounded or used bar notation. All right, let's do a few examples that are like the harder problems in the homework, those that we didn't get to in class. They use a combination of the product rule, the power rule, and the quotient rule. Number 88, the base is negative 4x squared, and that whole thing is raised to the negative 1. Well, I know that anything to the negative 1, that's to a negative exponent, so I could take the reciprocal of the base, and then that would be to the positive 1. Taking the reciprocal of the base makes this exponent positive. Notice when I took the reciprocal of negative 4, it didn't become positive 4. I didn't change the sign of the base, I changed the sign of the exponent. And then, of course, negative 4x squared to the first is just negative 4x squared. So you really don't need those parentheses at all, and you don't normally leave a negative in the denominator of a fraction. So the answer in the back of the book would either have that negative out front or you could write it in the numerator. Either of those two things are the same. But that was just using the definition of a negative exponent. Take the reciprocal of the base, and that makes the exponent positive. Number 92 is using the quotient rule. I can divide the x's using the quotient rule. I can divide the y's using the quotient rule. You may not need this middle step, but if you do, you could break that fraction apart and show that you're just dividing the x's and dividing the y's and then multiplying those two expressions together. I left off the negative on the exponent of the x there. The x in the denominator has an exponent of 1, which you don't have to write, but you can if it helps you. The exponent of this y is 1, which you can write if it helps you. And when you apply the quotient rule, subtract the bottom exponent from the top exponent. Negative 2 minus 1 is negative 3. So this first factor is equivalent to x to the negative 3. When you divide the y's by the quotient rule, subtract the bottom exponent from the top exponent. That gives you y to the negative 1. And then because I don't ever want to leave negative exponents in my answer, the directions and the homework and the test will say that. Don't leave negative exponents in your answer. Write that as 1 over x cubed y to the first. And of course, you don't have to write the exponent of the y. You do have to write that 1 in the numerator of the whole fraction. For example, if you took the reciprocal of 7, it's 1 over 7, and you have to write the 1. If you take the reciprocal of these guys, you have to write the 1 in the numerator as well. All right, 94 uses a combination of a couple rules. By the order of operations, I should remove these parentheses first, and that's a product raised to a power. The first power rule tells me that I can just raise each factor to the power. I can just raise the y to the negative 1 and the z to the negative 1. That denominator, I think this whole thing will be easier to simplify if I write that 2 cubed as 8, so that in the next step I can reduce that 4/8. And then I'm not doing anything with the x to the 4th y yet. Then I'm ready for simplifying the 4/8 and using the quotient rule on the x's and the y's. The 4/8 will reduce to a half. If I use the quotient rule on the x's, negative 2 minus 4 is negative 6. Notice I'm not worried about whether the x ends up in the numerator or denominator yet. I'm just writing down x to the negative 6, and I'll figure out where to put the x in my next step. Because it has a negative exponent, it's going to end up in the denominator, but I don't have to worry about that yet. For the y's, negative 1 minus that 1 in the denominator is negative 2. And I don't have anything to divide into that z to the negative 1, so I'm just going to keep up with it. Now I could take one more middle step before my final answer. I could write that x to the negative 6 as 1 over x to the 6th. I could write that y to the negative 2 as 1 over y squared, and I could write that z to the negative 1 as 1 over z. But if I just remember, these factors that have negative exponents are all going to end up in the denominator. I can see my final answer will be 1 over 2, that's the 1/2, with the x to the 6th y squared z in the denominator. I didn't take the reciprocal of the 1/2 because it didn't have a negative exponent. I only took the reciprocal of the x, the y, and the z. 96 shows you why I usually don't worry about positive and negative exponents to begin with. I don't flip this x and y and then flip the whole thing and make sure that I have flipped what I'm supposed to and not flipped what I'm supposed to. That gets confusing. I use the product rule, the power rule, and the quotient rule first. Like here, I use the quotient rule. And then as my very last step, anything with a negative exponent's going in the denominator. But my first step, I'm just going to use the power rule that says when you raise a power to a power, you multiply those. I'm also going to keep in mind that the 5 and the 6 both have their own exponents. They both have exponents of 1. And that negative 3 has to be multiplied by the 1's, just like the negative 3 has to be multiplied by the negative 2 here. So that numerator becomes 5 to the negative 3 times 1 is negative 3. X to the negative 3 times negative 2 is positive 6. In the denominator, 6 to the 1 times negative 3 is negative 3. And y to the negative 2 times negative 3 is positive 6. In your last step, you only want to take the reciprocal of those factors that have negative exponents. The 5 and the 6 have negative exponents. The x and the y don't have negative exponents. So the x is going to stay in the numerator, the y is going to stay in the denominator. But when you take the reciprocal of 5 cubed, or 5, when you take the reciprocal of 5, the 5 goes to the denominator, and that makes the exponent positive. When you take the reciprocal of the 6, it's going to the numerator, and then its exponent is positive. That's okay. If you leave that on the test, I would count it absolutely right. But since it's easy to evaluate 6 cube and 5 cube, I'd probably go ahead and do that. All right, that gives you some exponent examples that are roughly, or actually very closely, equivalent to those that you have in your homework. Just refer to the examples as necessary, and then email me if you have any trouble with the homework. Be sure you tell me what you've tried, not just I don't know how to do this problem. And for next class, you need to make sure that you do the orientation assignment, and section R.2 is assignment number 1, and bring these notes to you with you to our next class. I hope you've had a good first day of the semester, and I look forward to seeing you Thursday.